Alright, so with 41, you have a vector addition, and they've given you a part of this where you have AI, and you're just going to treat that I and that J just like some kind of constant. And they're telling you they took AI plus 3J, and they added to that negative 2I plus B times J. And whenever they did the sum, they had 6I minus 6J. And so what they're asking is, what are the possible values that we're going to get for A? So really, if we treat this as we're solving an equation, we would have to add 2 to 6. So that tells me that A, in this case, would have to be 8. And so notice automatically all these other choices are knocked out. Now, if you wanted to double check and make sure, then we would have to solve for B. We would have to subtract our 3. And so negative 6 minus 3, that tells me that B would have to be negative 9. So E is the correct answer. For 42, you're having to solve this equation. And notice the wording is the following an expression for B. So we're looking for B in terms of C. So notice C is going to be part of the answer. So you're looking for B equals. So we need to rearrange this. We're given that C equals B cubed, 10B cubed plus 50. And so what I'm going to work on is isolating this B cubed. So I'm going to subtract 50 over, just like you would any other equation to solve. I would divide by 10. And notice when you divide by 10, you have to divide every single part of the other side by 10. And that equals B cubed. And automatically we can see that here these are going to cancel that 50 over 10. So that's going to give us a 5 there. So we can cancel that. And notice that looking at our answer choices, there's really not much here left for us to finish on the problem, because with our equation with it rewritten, notice that we're already looking at C over 10 minus 5 equals B cubed. And so the only one that is anywhere near that would be your answer choice F, and that would be our final answer. Don't get so hung up on trying to get the problem completely finished, because you have 1 minute per problem, so you're going to get it narrowed down to a good answer and go with it. This notation means that we're going to take my function g and we're going to substitute it in over here at f everywhere I see an x. So f of g of x, that's going to be equal to x plus 1 all squared, because again I'm changing that x to x plus 1, plus 3 times x plus 1. Notice I don't have an answer choice yet, so I need to multiply these out. And do remember that x plus 1 all squared means x plus 1 times x plus 1 plus 3 times x plus 1. Still don't have an answer choice yet, so we're going to have to FOIL this out. So that's going to give us x squared plus x plus 1. And we're going to go ahead and do our distributive property over here. Now let's see, which one do we have? We have an x squared. So all of this, we don't have an x cubed anywhere. So that's going to get rid of the cube. And then we need to know, well, when we combine our like terms here, or we can even look at our constant term. Notice I have a 1 and a 3, so that's going to have to be 4, so that means we have answer choice A. Okay, for our next problem, we're told that we're actually comparing the area of the first circle to the second circle, so we do need to know our area formula of a triangle, or of a circle, which is pi r squared. And we know that here the diameter of the first circle, and I'm just going to go ahead and note area of the first circle. The diameter is 12, so that tells me that the radius is 6. Now it tells me for the second circle that the radius is, or the diameter is 25% longer. So in your calculators, to make quick work of this, you really need to take 12, and if it's 25% longer, then you can multiply by 1.25, and that's going to generate a 15 for you. That's going to give you the 25% more, so then you're adding that back to the 1. So here we're going to have 15 divided by 2, because we just found the diameter of the second one, squared. So in our calculators, we need to see, well, how much larger is the area? So in your calculators, I would take this larger portion, which is going to be 7.5 squared pi, and you need to subtract from that 6 squared, or 36 pi. And when you do that, you should get 63.6173. So that tells me roughly 64 would be how much larger. Okay, so for the next one, what is the product of the mean and median of the first 6 prime numbers? And use their hint here that they gave you, that 2 is the first prime number. So when we start listing out these, and I would just go ahead, you know what prime numbers are, the only factors are 1 and itself. So you got 2, 3, 5, 7, 11, and 13. Now mean, that means average. So here we need to find the average. And so we'll add these up, and it looks like I would try to add by 10. So we're going to have 20, 31, and then 41 by the time we add that back. So I have 41 over, and then we had a total of 6, didn't we? The first 6. So that's going to be the mean. Now we need the median, which is the one in the middle. However, we have an even amount, so we have to take 5 plus 7 and divide that by 2, and that's going to give us 6. So now if we find the product of these two, that's just going to give me 41. All right, so for number 46, we are dealing with the trigonometric identity. And the identity that they are testing us on here is going to be our sine squared of x plus cosine squared of x, and that's equal to 1. Now, this is always true when these two angles are the same. So really that's going to narrow us down to j and k. And then we notice that here we have the same angles, but this one's equal to 7, but it's always equal to 1, so my answer is K. On number 47, it'd be a good idea to go ahead and label what they've given us, which is telling us AD is 5 meters. So AD is over here. That's going to be 5 meters. And then the length of BD is 12. Now, from geometry, y'all were told that here, this is going to be from here to here. That's 180 degrees. And this intercepted arc length right here, this angle is half of this angle here. So that portion in there is going to be 90 degrees. Now that's important for us because then it sets up a right triangle. And we're going to have the Pythagorean Theorem. So we would be missing this side here. And whenever we do our Pythagorean Theorem, I'm going to call this side C. Well, not C squared, but C. And so I'm going to have 5 squared plus 12 squared equals C squared. And when I work this out, I'm going to get C to be 13. And so this whole length here is 13. Now the question itself is asking for the length of CD or DC. So it's asking for this length here. So that's really looks like it's incorporating the area of a triangle. So 1/2 base times height. And we need a nice little formula, and this is called Heron's formula, to find the area of a triangle when you just have the 3 sides. What you're going to do, the first thing, is you need to find the perimeter and divide that by 2. So the perimeter, again, we will add up all the sides. And let's see, that looks like that's going to give us 10, 25, 30. And if I divide that by 2, that's the semi-perimeter, and that's going to give me 15. So then that's going to lead to our area. It's going to be the square root, and it's going to be that semi-perimeter times, and then we're going to take that semi-perimeter and subtract each side. So minus 5 times 15 minus 12 times 15 minus 13. And so I would not multiply all this together. Don't do all that. I would actually break this down. 15 is 5 times 3. Well, 10 right here, so that's going to be another 5 times 2. That's going to give me 3, and then 2. So now I can simplify this radical, and that's going to give me my area. So let's go through and see. I'm going to see those are going to cancel, so that's going to give me 5 times 3 times 2. And so notice that's going to give me an area of 30. Now we're ready to do our area formula and finish this problem. So we saw that the area was 30 equals 1/2 our base, which is 13, times our height, which is what we're looking for. So I would multiply that 2 over, so that's going to give me 60 equals 13h, and then divide both sides by 13. So notice that the missing side is going to be 60 over 13. So that's going to give me answer choice A. Okay, number 48 is really kind of a tricky question. You are told that A is positive and B is negative, and you want to know which of the following is equivalent to the absolute value of A minus the absolute value of B. Well, I would pick a couple of numbers. Like I would say A is 4, and B can be any negative number, so I'm going to pick negative 5. And so over here, when I do the absolute value of 4 minus the absolute value of negative 5, I end up with 4 minus 5, which is negative 1. So now let's take those same values, and if I plug in each part here, here, and here, notice I'm going to get different values for that. The closest one is G. Now that's not the correct answer. I shouldn't have circled that. Let me get that away. But if I plug in 4 and negative 5, I'm going to get the absolute value of negative 1, which is positive 1, but I need something to equal a negative 1. And if you keep plugging in, you're going to see that K would be the correct one here, because again, that minus here is being maintained here. Okay, let's look at 49. And so we see that X is less than Y. Again, this is another kind of tricky problem, but maybe we can get through it. Here, X is less than Y, and Y is 4, less than 4. So I would look at a number line. Here is 4. Now, Y is less than 4, but I want the greatest possible integer value. So I want to know of X plus Y. So I'm going to pick a number super duper close to 4, and I'm going to say, okay, I'm going to let Y equal 3.9999 forever and ever, amen. Well, then I'm going to pick X to be just slightly smaller than that, but not a tremendous amount smaller. So I'm going to kind of butt up against that and say, well, I want X to be 3.98, repeating. So I see that X is indeed less than Y, and Y is less than 4. But if I add those two together, I'm going to be pretty darn close to 7, aren't I? So that's going to be answer choice D. Okay, moving on to number 50. We're talking about direct variation. And this problem, again, this is another one of their tricky problems. you have to come up with something called a constant of variation, and we normally label that letter K, and that's just a constant of variation. So what we're going to do, y varies directly as the square of x. If it varies directly, that means it's equal to. As y changes, the square of x changes. Now this is where that hidden constant variation comes into play, because really we're going to say that's times k, that constant of variation, because there's some hidden stuff here that we don't see happening. Now for your first x and y, you're going to sub in and solve for k. So that's always that first step. So we're going to have 20 equals 2 squared times k. So we see that our constant of variation is 5. So our second step with these, I'm going to have y equals, we solved for k, we got 5, and I'm just going to now rewrite our equation. And then we plug in our 3. So that's going to be y equals 5 times 3 squared, which hopefully today is 45, so yay. All right, moving on to the next. Okay, for 51, notice this is such a long problem that most people will stop reading it. I encourage you to skim through it, but at the same time, at the very end of it, look and see what it is asking. Which of the following equations represents an ellipse? Now, I know not everybody has seen an ellipse or the equation, and you don't have to know everything there is about it. You have that ellipse. Since the ellipse is turned on its side, since the ellipse is this way, that means the denominator under x, that x squared over number, is bigger than the one under y. So here, that one has the number, so that means just skim through and compare. Well, this 2 here, that's certainly not bigger than 5, so it can't be A, can't be B. Oh, no, it might be C, it might be D, and it might be E. So notice that we very quickly went through and eliminated 2 choices, and we don't even have a clue about what an ellipse does. Now, just a quick side note, if your ellipse was turned this way, then that means that the larger denominator is under your y squared. So make sure you have that in mind. Now, something else that we were told is that the larger circle, the larger the circle, has that equation. So that tells me that the radius there is 5 for the larger circle. So that tells me that this big O circle from here all the way out to here, that has a radius of 5. So if that's a radius of 5, and notice over here these numbers, it almost looks like it's going to be this, but believe it or not, it's going to be this one, because these bottom numbers are squared. So just your general equation is going to be x squared over a squared plus y squared over b squared, and that's always equal to 1. And again, the ellipse just depending on how it's turned. So here we were able to very quickly pick out it is answer choice D. Now for 52, this one's kind of a tricky problem as well. It seems like I'm saying that for these last few, but the mean of 5 integers is 52. So that means that when I add up 5 integers and I divide by 5, I get 52. And then it tells me the median of these 5 integers is 82. 3 of the integers, you have 0, 12, and 82. Which of the following could be one of the other integers? Now we have to be careful here. We do need to realize that there's 3 of them. So if I talked about the mean, then that would mean 0 plus 12 plus 82 plus these other 2 mystery numbers, and I divide those by, let's see, what am I going to divide by? 5. That's going to give me 52. So really the sum of these, let's go ahead and add these up. I'm going to have 94 plus x plus y is going to have to be equal to 260. And essentially, we could go ahead and keep solving this. We could subtract that 94 over. So really, I'm looking at the sum of those two numbers has to be 166. Okay, now the other thing that we have to look at is the median. The median is 82. So that means that our middle number is 82. Well, when we start looking at all the different ways and different possibilities, let's try our answer choices and see. So if we choose our answer choice, and I can just do a little chart here, and let's pick out some answer choices. And so if I let x be 52, and then I subtract over, if x is 52, then that would imply that y would then have to be, let's see, 114. And so now let's go back and check our median. So then the median, I'm going to label this median. If I go back and check that, well, if I'm putting in a 52 and 14, will our median still be 82? And when you check it, it's not. Now, a quick reminder on that median, it would have a 0. Our numbers, we would have 0, 12. Then we would have 52. And then we would have our, let's see, 52. Then we would have 82. And then we would have 114. And so our median would no longer be 82. And so then we can go back and I can check 66, and it's still going to generate a median of not 82, but right here, H, that one is so close to our actual median that it is going to actually generate our median that we need of 82. So if we throw in 82 or 84, then that's going to give me another number of 84. So there we go. We're not changing the value there. We're going to have those sandwiched, and so that would give our median is going to be 82. So yay, there it is. Okay, for 53, they're telling you that an abundant number or integer is a positive integer, and if the sum is greater than the actual integer itself. So how many of these integers are abundant? So I would take this largest one, of course, pick on that one first. Well, let's look at the factors. We have 1, 2, 3, 4, and let's see, 6, and we don't count 12 because it tells you greater than is without is included. So let's add this up. That's going to be 10, 13, 14, 15, 16. So 12 is abundant. Okay, let's go to 10. 1, 2, 5. Nope. And let's go to 8. So that's 1, 2, 4. That's 6, 7. That's close, but not quite. And then 6. We've got 1, 2, and 3. And nope, that one's not. So there is only one number here that is abundant. All right, so looking at our next one, we have this little chick. She walked at a rate of 2 miles an hour for 10 minutes. So she has 2 miles an hour for 10 minutes. And then she walked at a rate of 3 miles per hour for 5 minutes. And so what is her average rate in miles per hour over 15 minutes? So we're going to divide by 15, and because that's how many minutes she's got going on here. So we're going to have 20 plus 15 divided by 15. So 35 over 15. So that looks like we can reduce that by 5. So it's going to be 7/3. So we have G. Okay, so this one we have a ratio problem, and we are told that the ratio of A to B is 5 to 7, and the ratio of B to C is 4 to 3, and I want to know, well, what is the ratio of A to C? So I would cross multiply and get some information going on here. So I know 7A equals 5B. And so let's see, I want A to B, or A to C, so I'm going to solve for B here. And so I know B is really 7/5 A. So in this portion right here, I'm going to make that substitution. And so I'm going to have 7/5. I'm going to erase this over here. So I'm going to erase that, give us a little bit more room. So here in place of B, I'm going to put 7/5 A is to C, and that's equal to 4/3. Well, if I want to know A to B, well, really to move that over, I need to multiply by 5/7 to get that to cancel, and so it looks like my ratio of A to C is going to be 20 to 21, so that is D. Okay, so 56 is going to be working with our exponent rules, so which is not equivalent to all of that. Now, a side note here, the square root of x, that's really x to the 1/2 power. If you wanted the cube root of x, that's really x to the 1/3. And if you raise an exponent to an exponent, you are going to multiply those. So let's start doing some rewriting. Oh, and also something else we need to look at. If you have, let's say, the square root of x, and I'm going to just make a, that e is going to be the exponent, r is going to be the root, then that's going to be your exponent over root is how you would swap that. So starting out on the outermost, that's going to be something to the 1/2 power, and then this stuff on the inside, that's going to be x to the 2/3. And so now if I do an exponent raised to an exponent, I'm going to multiply, so that's going to be 2/6. So if I reduce that, that's going to be to the 1/3 power. Or that's the cube root of x. So, well, f is exactly the same. G, if I change g to be our fractional exponent, and I am out here to the side, it's going to be exponent over root. So that's x to the 2/6, which is the same thing as x to the 1/3. So it's not g. And let's see, it's not j. So we've narrowed it down to h or k. And let's look at, because we really don't want to deal with h, but look at k, x to the 2/3. Well, that's definitely not x to the 1/3. So my answer is k. Right, so for 57, we're talking about the length of a rectangle is increased by 25%. So I'm just going to assume all of this is out of 100. So if the length is increased by 25%, I'm going to say that's 1.25, the 0.25 dealing with the 25%. And so if we are decreasing by 10%, then that means I have a 0.9. Side width. And so when I look at the area of this, area is length times width. So I have 1.25 times 0.90. And when I multiply that out, I get 1.125. So really right here is our percent increase. So if we look at 0.125, we're going to multiply that by 100 to make it a percent. Sorry, it is a decimal. So I get 12.5%, which is answer choice B. Right? So 58, 5 balls are numbered 1 through 5. They're placed into a bin. 2 balls are drawn at random without replacement. what is the probability that the sum of the numbers on the balls drawn is 7? So let's think about, with these list of numbers, how can I get a 7? Well, I can draw a 4 and then a 3. And so if that's a possibility, so 4 and then a 3, and that's out of a total of 5 balls there, right? So how many ways could I draw 4? Well, there's 1 out of the 5. And I would have to draw a 3, so that was going to be a 1 out of the remaining 4. So notice I put our multiplication here. If you see a multiplication with probability, that's including the word and, because I would have to draw a 4 and a 3 to find what I need. Or, so I'm going to put a plus sign because I can say or here. And it looks like 2 and 5. So I could pick a 2 and a 5. Well, how many ways can I pick a 2? Well, 1 of the remaining 5. And I would have to choose a 5, so that would be 1 of the remaining 4. And so I'm going to have to, oh my gracious, that's 1 out of 20 plus 1 out of 20. So that's going to give me 2 out of 20, which is a 10th. But now that's choosing a 4 and a 3. But what if I wanted to choose 3 and 4? What if I change the order of it? And the same thing here. So that means I have a whole nother 2 sets. So I'm going to multiply that by 2. So 1/10 times 2 is going to give me 1/5. So that's going to be answer choice F. Okay, so for 59, we're giving the parent function sine x plus c. And which of the following is the only possibility that y has no x-intercepts? In other words, we don't cross the x-axis. So let's look at some of our shifts with parent functions. Now sine x, if we graph sine x, it looks something like this. And the highest that it goes, and my drawing of course is horrible, but sine x is bounded between positive and negative 1. So if we're adding c, then that means that that plus c is either going to move this up or it's going to move it down. So what values would I need in order to make sure this entire graph is moved up to the point where it does not cross the x-axis? Well, that would mean that either I have to be either less than negative 1 or I have to be greater than positive 1. So which graph represents that? It looks like it's going to be answer choice D. All right, so our next question, this person is calculating that she needs 360 square feet of new carpet. All right, but the type of carpet she wants is priced by the yard. How many square yards of carpet does she need? Well, let's see, for yard, I know that there's 3 feet per 1 yard. That's what I know. Yay. So really, to do our conversions, I need to flip that over. So let's flip that over and make that, I want to say, let's flip it. And so that'll be, well, my son just sneezed. So let's flip this, and you're going to get 1 yard per 3 feet. And the reason why I'm saying flip that over is because we need to end in yards, so we definitely want that to be in our numerator. He just sneezed again, bless him. And let's see, we're talking about square yards, so I need to square all of that. So that's going to be 1 yard squared over 9 feet squared. And now we can do our conversion, because we are going to change that 360 square feet per 1 yard. And so we want those to cancel. And notice you're going to look at 9 dividing into 360. And that's going to tell us how many yards squared. So That looks like that might be a good old 40.